Welcome everyone, can you hear me? Cool, cool. Let's start our karaoke night. So yeah, my name is Pavlo Golub, and today my talk is about monitoring PostgreSQL. So I'm a senior consultant slash developer. I mean, at least they call me so. I prefer to think of myself as I'm a young developer and handsome, but I mean, yeah. So I work for Cybertec. This is the Austrian-based company, but with some branches. So we don't have a branch in the United States yet, but we have a branch in Uruguay, for example, which is like the same time zone if you need our services. So who we are the Postgres company. That means that you can have any tech stack you want, but you can be our client only if you run Postgres. What if you don't have a Postgres? We can run it for you, and you can be our client. So these are some of our products for PostgreSQL. So scale field is like AWS, but on your own hardware. Cypex is the analog of Apex for Oracle. You can create application quickly. Migrator is here to migrate your databases from Oracle, MSQL, and other databases. And Pgwatch means Enterprise Edition, including transport database, the data encryption, is here to help with some specific issues. Okay, agenda. I will tell you about like different levels of monitoring, different approaches. Then I will show you what tools do we have in PostgreSQL universe. And then I will show you live demo of Pgwatch tool. I'm a maintainer now of Pgwatch. This is open source tool. You can use it for free. And I will show you what you can and how you can monitor Postgres with it. Okay, so first question, why do we want to monitor it all? Simple question and stupid, right? We want to know if our database is up or down. We want to know, is it slow or fast? We want to know how many money we need to run our databases, right? And we want to have like some idea or some predictions. I mean, what will be with our system during Black Friday, for example, right? So different levels of database monitoring. High-level service monitoring is like if I'm running or not, then system monitoring if the operating system dependent or cloud or Kubernetes or what we have. And the third one is PostgreSQL specific, right? So as I said, high level, we want to have some kind of script, whatever, that will constantly ask our database, are you live or not? Are you live or not? If it's okay. So, but how we can be sure that our script is good enough, and how can we check that like everything is run smoothly? Another thing is like system monitoring. As you probably know, PostgreSQL is operating system agnostic. It doesn't care for it if it's running on Linux, on Windows, or whatever. It uses like the same approaches everywhere. And that's why like for every operating system, for every environment, you have like different metrics, and usually you want to know what are those metrics and what do they mean. Like what is CPU load, what is memory, and all other things, right? If we are talking about PostgreSQL specifically, we can split these into three main categories. Log analysis, statistics collector, which is the part of PostgreSQL, and the extensions. Some extensions, like third party, that are available to use in Postgres. Many people don't know that everything goes to log first. If you need to find error, if you need to find the reason of what's happening wrong, or what's wrong with the system, everything in the logs. Yeah, it's like old-fashioned way, but that's how Postgres works. So usually there are two approaches. You can just grab your logs and save them somewhere, so you can later analyze to find the reason of your problems or performance issues, or you can use special tools for active parsing of the logs. I would say that standard de facto nowadays is Pgwatch. It's used a lot. It's a very cool tool. It's mature and very solid. So yeah, if you want to parse your logs, just give it a chance. Of course, we have like a lot of like different other parsing solutions. Nowadays, we can use Grafana Loki and some specific cloud services. Yeah. Oh, okay, here we are. But before we will have everything in our logs, we need to somehow to set up our logs. As you can see, like in the latest Postgres 17, there are 43 different parameters to set up your logging and reporting. The main are the destination, so how we store our logs, like CSV is probably way to go. Someone may use JSON, but it will like a little bit chatty, so you will have like bloating logs. But for Pgwatch, it's the best solution. You want to say log mean duration statements and log duration. I mean, after what period of time your statement will go to the log. And yeah, messages, what kind of messages you want to have, like, as I said, 43 different parameters. Statistic collector. A statistics collector is a part of PostgreSQL itself. So this is the facility, this is the machinery that gathers the internal information and save it for you, and you can query it using the regular SQL. Of course, not everything is owned by default. So the parameters responsible for statistic collector started with the track prefix. So if you want to enable as much as possible, you can go just and enable it. We can divide the statistics collector into two kind of views, system views. The first one is dynamic. It shows us what's going on right now. How many connections? How many queries? How many logs? How long this and that query is running, right? And cumulative views, which shows us the information from the last statistic reset. How many statements were executed? How many the average time of this query, or the sum of the time of this query, that kind of things. And the thing is, if you are a consultant, or if you're like a client and you need to like investigate what's going on with the system, the first thing you want to do is just to reset the statistics. Then you want to spend like a day or maybe two collecting the workflow data, how it's going on, and then you can do some kind of analysis based on it, right? Extensions, there are a lot of them. This is the philosophy behind the Postgres. So we have like the main things in our core, but if anything can be done in extension, that's the way to implement it. The first one is a pgstat statements. Extension, it's available in contrib in every installation, so you just like enable it and it's there. No need to install, no need to rebuild, it's there. The next one, pgstat monitor, made by Percona, probably, yes, made by Percona. It's based on pgstat statements, but it gives you even more. So if pgstat statements is not enough, you can go to pgstat monitor. It's open source. All extensions listed here are open source. The next one is pgstat tuple. So if you want to know if your tables or indexes are bloated, you can use this one and examine what's going on inside. PG buffer cache allows you to see what's in a buffer cache of your system. Auto-explain is a good one. It allows you to send long queries to your log. Not only the text of the queries, but plan that was used for this query. For example, if the plan was bad and you will see it in log, you will say, oh, something went wrong, and you can maybe update your statistics or maybe rewrite your query, something like that. Pgwatch stats allows you to see the statistics about the where predicates, and pgstat cache allows you to examine some operating system metrics. This is mostly Linux. I'm not aware that there is like version available for Windows, and more, even more. What's going on in real life? Real life is not easy, right? So usually we are doing kind of mix of things. We do log collection and parsing. We do like some snapshotting of PG stats, and we're trying to play with all this data somehow. So yeah, what tools are available specifically for PostgreSQL monitoring? There are a lot of them. We have a wiki page named monitoring. I would say that like 20 plus tools are listed there. Probably not all of them are up to date, but I mean, you need to check this out. Ad hoc troubleshooting. Sometimes you don't need to collect data to see if your application is going okay or not. So sometimes you just want to connect to the system and check what are the current values for some things, right? So for this, you can use like PG activity is my favorite one, PG center, PG top, PG hero, PG admin in dbeaver. So PG activity looks like this. Let me show you. I have it some running. So okay, so this is, can you see it? This is how it looks like. So now our system is idle, so let's start some workload. And now you can see that something is going on. Well, the upper rows will tell you about like some details about the database you're connected to. Uptime, the size, the growth, the sessions, the number of different things. And now you can see like something is going on. So the first tab is running queries. So we can see that some application PG bench under user Pgwatch is running some queries, and they produce some waiting events, right? So for example, I use this tool a lot. So instead of app, when I use like some ETL complicated things, I name every stage with a number. So I knew exactly on what stage my long process is on right now and what problem they might produce. So you can switch to different tabs and see waiting queries, blocking queries. You can put it on pause, and etc. This is good like for ad hoc monitoring. There are two graphical user interface applications, Pgadmin and dbeaver. They have the simplest dashboards. They are not really for monitoring, but just to give you the idea how your server, how your database is working. dbeaver only have 3 dashboards, but the thing is, it's open source, so you can add more. And since we are able to write queries to have the information from the statistic collector, we can build very sophisticated dashboard tool. For continuous monitoring, for tools, what about tools that are collecting the information and then allow you to analyze what's going on. There are plenty of commercial agents like AppDynamics, Datadogs, and EDB, Enterprise Manager. There are, of course, some open source, Negios, Async, Munin, Zabbix. All of them are based on the well-known check Postgres script that is available freely on GitHub. And there are very specific monitoring tools that focused only on Postgres, and that's it, like PgHero, POVA. By the way, the POVA team is responsible for the cold starts and start Kcache extensions. This is the same team. pgclue, the pgstatwiz is the very young solution, like maybe 2 years. It's very simple. It's just like do snapshots of your statistic collector and then build automatically the images for you so you can just see what's going on. And Pgwatch. Pgwatch, why Pgwatch and why 2, right? So there is a rumor that Pgwatch 1, nobody saw it. There is a rumor that was just like a Python script running and constantly snapshotting all the system collector. But later, my colleague, Karl Moppel, the author of Pgwatch 2, decided to rewrite everything in a proper way because we, as a consulting and supporting company, needed the tool to work with our clients and to monitor their services. So main principles and how the Pgwatch is different from all others too. So the idea was to have like one solid binary. That's why we used Go language. And we decided that the main way to install it would be like a Docker image. So you just provide the command line for your client, for your user. It just started, and that's it. And it's ready to accumulate the data. We wanted it to be non-invasive. That means you don't need super user permissions, or you don't need some kind of elevated privileges to run it. And of course, we wanted to have like dashboards there, and we wanted to make these dashboards changeable, right? So you can update those for your needs. And what is the architecture? As I said, the main part is a Golang application that will gather all the data. You can configure it with database or file in YAML format, or with environment variables. Then we need to put somewhere our metrics, right? So the most obvious solution for Postgres people is to use Postgres as a measurement layer. So we started with PostgreSQL. Then we added opportunity to use TimescaleDB. TimescaleDB allows you to shrink the data, to compress it like 10 times maybe. That's very cool. And it allows you to use more sophisticated querying. Our first storage layer was InfluxDB. At that time, we thought, okay, InfluxDB, it's a time series database. Probably they know how to store and how to do things. But later, we discovered that Postgres is like on the same level of, but the SQL is much richer. So at that time, we deprecated the support on InfluxDB and Grafana. Nowadays, the standard de facto in monitoring world is Prometheus. So of course, we allow to scrape everything into Prometheus. And if you have your Prometheus, of course, you can do like alerting, you can do your own dashboards, and you can do all the stuff you want. And we allow you to store your measurements into local file. Why? I mean, sometimes you need to analyze it, or maybe you want to use some kind of AI to tell you what's going on with this data, etc. So the next one component is the web UI for administration. For example, if you want to add a database under monitoring, So, I mean, the idea is our, Web UI for administration and Grafana for dashboarding, right? So this, how it looks like. So this guy is a metric collector. It connects to zillion PostgreSQL databases. If some of them has Python U means untrusted. That means you can access some system metrics like CPU, memory, or disk. If not, we are fine. We don't need that, actually. Then it gathers every metric, and it stores it in the storage layer of your choice. And here's the configuration, different kind files, databases, whatever. So when you apply some changes to configuration, this guy reads it and connects to new databases or use new metrics and stores it here. Then you, as a user, open the Grafana dashboard, which connects to the measurements layer, and you have different dashboards. By default, we have like 20-something, and you can use it, right? What else? So not only Postgres is like the point of our interest. For example, we have like things like pgbouncer and pgpool, and we want to know their metrics as well. Or we want to monitor every Patroni cluster member. So we add auto discovery. Or we want to add some more metrics. So this solution, the Pgwatch, is like very flexible. So it is under your control. Alerting previously in previous Grafana versions, there were possibilities to use built-in alerting in the dashboard. But as far as I know, the latest Grafana decided to remove the alert support. So nowadays, the best solution probably is to use the built-in Prometheus alerter, or to have your own one based on pgcron or pgtimetable. Just constantly check the values and conditions you have, and then just issue the alert. So how one can see and touch what the Pgwatch is, the easiest way is just to start the Docker image, which has everything in it. So Pgwatch to Postgres means that this image has Postgres as a measurement layer and Pgwatch combined Grafana. So you start it, and you have like Grafana on port 3000 and Web UI on port 8080. But if you don't want to run it, just go to the demo pgwatch.com, and you will have the idea. So let's check what we have here. So this is demo Pgwatch. So the first dashboard you will probably start with is health check. It's kind of, I mean, all dashboards are made by us, but you are not limited in no way to use them. You can customize it, and in fact, you should customize it. For example, the longest query runtime here, it shows like orange, right? So there is kind of threshold, like for 10 seconds or something. But if your system is okay running long queries, you need to increase the threshold so everything will be green and you are fine, right? So as you can see, we have a lot of different built-in dashboards. But as I said, you are not limited to them. For example, our colleagues, our friends from Postgres AI company, they created their own set of dashboards. So the idea is they are using the same Pgwatch, the same gatherer, the same metrics, everything the same, but different dashboards. Why? Well, they say it's very complicated for a person to understand like different, to have more than 10 dashboards. I mean, why do we have like 10s? Like, why don't we have like 5? So they divided everything, every dashboard, every metrics, they divide into 5 layers. First one is like the global database overviews, like what is your cluster, how is going on. The next one, I want to see how each of my databases is going on. Then, okay, we go down on the statements level. What queries do we have? Logs, how long are they executed, etc., etc. Then I'm interested in tables. Are they bloated? Any other problems? And index overview. And the thing is, so their dashboard is very long. As you can see on my laptop, it's like maybe 4 screen. So if you have like a big screen in your office and you can put everything there, maybe it's okay. But I prefer like, to have only 4 or 5 panels, so I know what exactly I'm looking for. Yeah, so for investigation, this is cool. For example, this is the global overview. This is the per database overview. You can choose the database and you will see like different statistics like transactions per second, queries per second, etc., etc. Okay. Now, let's return to our slides. Okay, so now Pgwatch 3, the next major version. So we are now at the point where we have beta 6. It's not officially released because I'm a maintainer, by the way. So the thing is, Carl left our company after the COVID. He decided to spend more time with the family and dogs. And my chef approached to me and said, "Oh, probably you are the one guy who knows Go and who knows how the monitoring things is working." Yeah, this is my chef, the Hans-Jürgen Schoenig. And he said, "Okay, so you will be like responsible for Pgwatch." And I'm just like, oh, that's not like what I was dreaming, but I mean, on my conditions, right? So I want to rewrite some of the code because like it was made as a single Go file, and you easily can like lose the idea what is happening on what level. So, and from that period, it was like maybe a year and a half ago or 2 years, I pushed a lot of efforts into this. So yeah, this is how the web UI looked before. This is how it looks now. Like before, now. Dashboards before, dashboards now. The thing is that the Pgwatch 2, the current deprecated version, is using like the exact version of Grafana. So for example, if you have like the Grafana 7 in your environment, you can use it, but it's kind of non-trivial to force it to work. In the third major version, we decided that we are not sticking to any versions, that if you have something and you want to use it, you are free to go. And among other things, as I said, we allow to use TimescaleDB out of the box. So for example, this is the real data, like for half a year, for 6 databases, real data, for 3 months, the current storage in PostgreSQL will consume 70 gigabytes. But if you use TimescaleDB as a storage layer, it will be 8 gigabytes, like 9 times less, right? And right now we are working on a new storage implementation that will even make it less. So like from 11 gigabytes without TimescaleDB to like less than gigabyte. That would be cool. And the thing is that you are not limited anymore to Postgres or TimescaleDB as a storage layer. In fact, you can use any Postgres flavor like Citus or Aurora or name it. You just need to speak Postgres-ish and you are fine, right? Other things, we decided that it's not wise to limit a storage layer. For example, we have some clients that say, okay, we need a copy of measurements for our own purpose. So okay, we can like provide you with measurements, but we need a copy. Okay, so right now you just can start a new Pgwatch and specify several storages. Like in here, you are specifying JSON file, you are specifying PostgreSQL, and you are specifying Prometheus at the same time. And you can add even more, another Postgres, another Prometheus on another port, another JSON file, just name it. The idea behind it, because for some different metric storages, you want to have different retention periods. For example, I'm fine to store JSON like six months ago, right? So I just push it to S3 and I'm fine. But I don't want to store like more than 2 weeks in my PostgreSQL, right? So this is how you can do it. And of course, Dockers are much slimmer right now. So first of all, we renamed the Pgwatch to allow people understand that this is like a demo image. So it's okay to run it like for a day or two to check your things or to collect some data. But if you are going to production, you want to use this Pgwatch. And the way you are doing it is probably using Docker Compose files. Okay, so let me show some things. So here we have database, yes. So this is my Docker Compose files. Probably this one is much better. So PG activity image I've shown you. So the Grafana, the Postgres, and Pgwatch itself, right? So usually, if you have Postgres somewhere in your environment, or if you have a Grafana in your environment, the only thing you need is just Pgwatch. You run it, you specify the connection strings for Grafana, for metric storage layer, and you are fine to go. So let's check what version do we have here. Oh, not bad. Can you see it? 17.0. Okay, so I told you that we have how many? So we have 48 different statistics views, and they are covering every possible aspect. Like you can see I/O, you can see tables, you can see walls, you can see transactions, you can see everything. And we are working on it, so every major Postgres version adds 2 or 3 more. For example, in 17th, we added the system view about copy progress and something else. Okay, so let's start some workload. So this is like a pgbench tool that produces some workload on our database. And now we can see, so I'm opening localhost 3000, and this is like the Grafana dashboard that allows you to see what's going on. As I told you, we have a lot of them, you can see. So yeah. The first one is the health check. Another one probably will be database overview. So here you just choose like the range, and then you choose like the interval on which you want to aggregate, and you can see like different panels. How we can use it? I mean, the Grafana dashboard, how we can use it to find like the slowest probably queries or the problematic queries we have. So we have a special dashboards, several, in fact, based on stat statements, pgstat statements. So can you see it? Maybe. So here you will find like 3 panels, and the first shows you top queries by total runtime. This is like probably the one that you're interested in. So if you can see, like the first query total runs 2.5 hours, right? That's probably the best candidate to fix. Others are not that really. So in total 9 seconds, it's like nothing. So sometimes people tend to look like average runtime or number of calls. That tells you nothing, right? You are interested in the total runtime. Another question is usually how Pgwatch affects the monitoring databases. Because Pgwatch uses queries to query the metrics, we can check this. Every Pgwatch query has a Pgwatch comment in it, so you can easily find it. So as you can see here, there is none queries by total runtime generated by Pgwatch too. But if we, and even, I mean, so this is not like a real production system, it's a demonstration. But anyway, you cannot see like system Pgwatch queries here. That means like the load produced by Pgwatch is like absolutely negligible. So how can we add databases under monitor? So this is the web UI. Of course, you can use like REST API or automatic like generation of YAML files, whatever. But if you prefer like clicking buttons, here we are. So we have 4 tabs. First one is sources. Sources is where we get our metrics. Next one is metrics that has our definition of metrics. So, for example, for, I don't know, for DB stats, we can check the SQL. And here you can see that there are some different queries for every version. So, for example, for 11, we have this one, for 12, this one, for 15, this one. Why? Because with every major version, the statistic collector is changing, adding or removing some columns. So first that Pgwatch does, it's checking the version of the database under monitoring and then applying the appropriate query for it. But it would be like not really easy, right? To, for example, by default, so we have 72 built-in metrics. And if you want to apply all 72 metrics to your monitoring database, it will be not easy to click every checkbox. That's why we have the preset. Preset means the collection of predefined metrics that you can apply. For example, for basic, we have only we have only 3 metrics. We will check size of the database, we will check statistics for the database, and we will check walls. But for example, for full, we will have like every kind of metric enabled, and you can see that every metric in preset has its own interval. For example, for recommendations, we don't want to run it every second. We want to run it like once or twice per day, right? Or, for example, for table bloating, we know that there's no need to run it every hour. We need to compare like every day or 2, something like that. So you can create your own presets or edit the built-in and set your own intervals. Okay. So how can we add how can we add new source? So first of all, source doesn't mean the database. I mean, source is a database with a matrix applied. So for example, I have a database demo, right? And I want to have two sources for the same databases. One will be with the simplest metrics for a day, and another would be like with the every like metric enabled like possible for like, I don't know, for Black Friday or for something. So the unique name is not the name of database, but it's the name of the source pass demo that will describe our database. Then we use our connection string. In connection string, you can use not only the user host database, but you can set any settings in it or application name, for example, like something like that. Then we have a type of the source. The simplest one is a Postgres, which means like a simple database. Then we have Postgres continuous discovery. What does it mean? That means, for example, if your cluster is very dynamic and you have a lot of databases in it, and you create them and delete them all the time, users come, users go, and you create every time and then. So you can use like Postgres continuous discovery. What it does, it connects to your cluster. It lists every database you have, and all of them it adds under monitoring. So, and it does it like every 2 minutes, as far as I know, by default, but you can change it. So for example, after 2 minutes, it will find that some databases are gone, it will remove it from monitoring and add new. So this way, you always have the up to date the list of databases. Another one is Pgbouncer and Pgpool. These are special sources for bouncer and pooler. And here you can see we have Patroni continuous discovery, Patroni namespace discovery. So the first one is for a Patroni member. The next one is for Patroni cluster. It will connect to etcd and will ask how many members do you have? What are those status, primary or replica or whatever, and it will gather and add all of them under monitoring. And the last one, namespace discovery, is if your etcd has several Patroni clusters, so you can specify the namespace, and we will scan every Patroni cluster available, and we'll add all of them at once. Okay, I told you that you can specify either the metric by metric or a preset. So here we can go with the basic preset. We have some specific presets for clouds, for GC, what is it, Google, whatever. Or, one more thing. So we can specify different presets or different metrics depending on the role you have. For example, if your database cluster is primary, we want to have like one set of metrics. But if this like a replica, we don't need to like to stress it. Like we want to know if it's alive or not, and if it's lagging behind like the, so yeah. So we can use preset or we can use metrics. So here we can specify metric by metric. As I told you, we have 72 of them. So you can choose, okay, I want this one, I want this one, and I want this one. Okay. And another thing is a tag. So since we can add the same database with the different metrics under monitoring, sometimes we want to distinguish it, right? So for example, for this one, I will say this is the best database, let it be one, right? Or I can add like, for example, if we have several instances of Pgwatch, we can say, okay, this database is monitored by this instance, and this one is by that instance. So we are free to add anything. And yeah, we just add source, and as you can see, we have this same database, but with different set of metrics, with different set of intervals, etc. After some time, usually 1 minute, the Pgwatch will refetch the information about new databases and will start collecting new data. The new database will be shown here. So as soon as the new metrics will be saved into the metric storage, your Grafana dashboard will see the new database, and you can start browsing it. It's not a real time, so it's not like you want to, oh, you just said, where is it? I don't see it. No, it's not. So if you want it to be like immediately, we have a special REST API endpoints in Pgwatch where just like reread configuration, it will do it, and like eventually it will start to collect the metrics. Another way, you just can kill the Pgwatch and start it again. It's just like absolutely harmless. You can do it like 100 times a day. It will just reread the configuration and start to collect new metrics. That's probably the most important things I wanted to say. We have 3 minutes left. So if you have any questions, this is the right time to ask. Hey.
Hi.
Yeah, fine.
I have a question. You were mentioning that across several Postgres versions, they were adding more molecule, more views for the molecule. But this tool, does it have a minimum Postgres version, or does it support?
Yeah, cool question. So the Pgwatch 2, which is still available, it supports minimum 9.0. It's way too old. Why? As I said, we made this tool for our own purposes, and we have clients with very old instances, and we cannot upgrade those. So we still like support 9.0 for them. The Pgwatch 3, which will be released tomorrow, I hope, the minimum version is 11. So it's already one version behind the oldest supported one. So the 12 is the oldest supported by community. So we decided that 11 is a good one. So yeah.
Yeah, and if you remember, I used Grafana a lot, and Grafana 6, which is kind of recent, uses Postgres 9.4.
Oh.
That was why I test. You didn't say that, well, this talks with Cyrus, this talks with Timescale. I imagine that you didn't try Grafana, but I would like to try.
We haven't tried, but I think it will work. Yeah, it's nothing there that will prevent it to work. If you support JSON-B, so that will work. Yeah.
I thought that this can be used for the cloud database.
Yes, it can be used for cloud databases because every metric is SQL. The only limitation for CPU memory and disks that we cannot get from clouds, but we don't need to because probably you will have your own dashboard from a cloud provider.
In what circumstances should we use Pgwatch over the cloud native monitoring methodology?
It's not a matter of like whether Pgwatch has more information or like different dashboards. It's more like if you have like different kind of environments, cloud, on-prem, different versions, then you can cover all of them with Pgwatch, but you cannot cover all of them with your cloud dashboarding. That's I'm not aware. Probably every cloud provider has its own. But I mean, nowadays, probably all of them are covered because you want to provide your clients with the most, like, with everything you have, right? And it's not really complicated to provide. You just run a query and you're done, and everything already there. The hard part is to come with a dashboard that will, like, suit everybody's needs. That is, like, impossible. Every person is unique, and I want this dashboard, I want that, and so. But if you have, like, a metric information, you are fine, right? Okay, thank you very much.